Hi friends, in this video we are going to see digital signal processing part 2 filtering week 1 quiz solutions. Let's take the quiz. First one, among the choices below select all the linear systems. Here we have the first one, the first option, the scrambling, like the permutation to the input sequence. Now see we have the 5 input samples x1 to x5 and the 5 output samples. All are the 1-to-1 mappings, so the system is linear. So I am writing the first option, which is scrambling, which is a 1-to-1, so it is a linear. And observe this relation. So x32 is mapped to the y1, then the x5 is mapped to the y2. So there is no proper time relation among the input and output systems. So it is not the time invariant system. So it is time variant. Okay. Now the second option, AM radio modulation. So the AM radio modulation is y of n is equal to x of n cos 2 pi omega c n. This is the first option, let us say. The second option, y of n is equal to x of n cos of 2 pi omega c n. Okay, now see, here this system is satisfying the superposition principle. So it is linear, but it is varying with respect to here the input output relationship is depending on the time parameter, so it is simply time invariant. For that you can check transformation of a1 x1 of n plus a2 x2 of n, that should be equal to the a1 y1 of n plus a2 y2 of n. So it is a linear, and the response of a system to a shifted input sequence is equal to the shifted response. Okay, this was not happen for the modulated signals. Okay, we'll see, that is t of x of n minus k. The response of a system to a shifted input is, it is x of n minus k into cos of 2 pi omega c n. Now if we find the shifted response, y of n minus k is x of n minus k into cos of 2 pi omega c into n minus k. So these two are not equal. So it is time variant system. So it is a linear and the time variant system. Now see the third option, second differentiation. Second differentiation, that is y of t is equal to d square by dt square of x of t. So again, which is linear, and it is also time invariant system. Time input output relationship is simply independent of time. Now d, the y of t is equal to x of alpha t. Y of t is equal to x of alpha t. Now see here, the relation is depending on the time, alpha into t. Simply it is a time variant, and the system is linear. The system is linear. The next, dtft of x. dtft of x. So dtft of x. This is again, the system is linear, but it is depending on the time, so time variant. The next one, f, y of n is equal to mod x of n whole square convolution with x of n. So y of n is equal to mod x of n whole square convolution with h of n. Simply because of the square, simply you can say it is a non-linear, but it is a time invariant system. Next, option G, y of n is equal to x of n. Its value is equal to the x of n, where x of n is less than or equal to m, and its value is equal to the m else. Now see here, the input is equal to the output in the x of n. The magnitude of input sample is less than or equal to m. In case that exceeds the value, then its value m. That directly shows it is the non-linear. It is non-linear, but the relation is not depending on the time, so it is time invariant. Okay. Now see, the first question we need to mark which systems are the linear and which systems are the linear systems. So the scrambling is a linear, and the next AM radio modulation, which is again the linear. Second derivative is a linear, and y of t is equal to x of alpha t is linear, and DTFT function is also the linear, and this convolution function is non-linear, and the clipping is also the non-linear. The remaining all are linear. Now see, second one, among the choices below, select all the time invariant systems. Okay. Now here also the same options we have. The first question, the clipping. So just now we discussed that the clipping is non-linear but time invariant. Now this envelope detector, this again it is non-linear but time invariant. Now this scrambling is linear but time variant, so it is time variant system. Now the modulation function is also the linear and time modulation function. We proved that it is linear but the time variant. Next, y of t is equal to x of alpha t is also time variant, and the DTFT is also the time variant function. Second derivative is the time invariant, so remaining all are the time variant. Now the third one, the impulse response of a room can be recorded by producing a sharp noise in a silent room, thereby capturing the scattering of the sound produced by the walls. The impulse response h of n was measured by the Progamming by recording the sound of balloons being popped. The balloon is popped at the time n is equal to 0, and after a number of n sound, the reverberation die out. That is, h of n is 0 for n less than 0 or n is greater than n. So they clearly given that third question, given that the impulse response is 0 for n is less than 0 or n is greater than capital N. N is greater than capital N. So that indicates the impulse response is finite. So the system is a fair system. So we know that FIR systems are always stable, and the impulse response is 0 for the negative time, so it is causal. Okay, now see the options. It is not the IAR, and it is a stable, and it is causal. Okay, next the fourth one, that h of n is equal to del of n minus del of n minus 1, and x of n is equal to 1 for positive time and 0 else, and y of n is equal to x of n is convoluted with, simply we need to find the convolutions. So we need to find the 4 samples, y of minus 1, 0, 1 and 2. Now see the fourth one. So given the impulse response, h of n is equal to del of n minus del of n minus 1. You can write this as a sequence form 1 and minus 1. Next, the x of n is, it is 1 for positive time, it is 0 else. It is 0 else. Okay. Now convolution, y of n is equal to summation m from, directly I am writing the 0 to 1, h of m x of n minus m. So we need to find the 4 values of y, that is at minus 1, 0, 1, 2. So the first y of minus 1, which is summation m from 0 to 1, h of m x of minus 1 minus m. So when I are expanding this, h of 0 into x of minus 1 plus h of 1 x of minus 2, which value is simply 0. Why? Because the input sequence x of n for negative times is 0. So 0 into something is 0. So next, y of 0, that is summation m from 0 to 1, h of m x of minus m. So its value is h of 0 into x of 0 plus h of 1 into x of minus 1. So this second term is 0. Why? Because the input for negative time is 0. So h of 0 and x of 0 both are 1. So product is 1. Next, y of 1, summation m from 0 to 1, h of m x of 1 minus m. So its value is h of 0 into x of 1 plus h of 1 into x of 0. So it is h of 0 is 1 into x of 1 is 1 plus minus 1 into 1. So it is 0. Next, y of 2, summation m from 0 to 1, h of m into x of 2 minus m. Value is h of 0 into x of 2 plus h of 1 into x of 1. So it is 1 into 1 plus minus 1 into 1. So the value is 0. Okay. Now the result is the 4 samples 0, 1, 0, 0. Okay. So 0, 1, double 0. So we need to enter these 4 values by separating the commas. 0, 1, 0, 0. Okay. Next, fifth one. Here the problem is similar to the previous question. The difference is here the input is n for positive time and it is 0 for remaining times. Okay. Now, so I need to find again the convolution between these two. So you'll see h of n is simply 1 minus 1 and x of n I'm writing as 1, 2, 3 and so on as a function. In here I am written as a sequence form. So we need the 4 values, y of minus 1, y of 0, so y of 1 and y of 2. For that what I am doing is I am taking the sequence h of n like this, 0, 1, minus 1, we start at 0. Okay, here I am using the matrix method for easy evaluation. So it is 1, 2, sorry, it is like, it is 0, 1. This is the origin. Zero, 1, 2 and so on. This is x of n and I am taking the y of n here. So it is 0, 1, minus 1. This is my origin point. So 0, 0, 0, 0, 1, 2, 0 minus 1 minus 2. Now the sequence is 0 0 1 1 minus 2. Okay, now which one is origin here? So this is origin, means for x of n this is origin, the product is here, so this is the origin. So this is at n is equal to minus 1 0 1 and 2. So the four values is y of minus 1 is 0, y of 0 is also the 0, y of 1 is 1, y of 2 is 1. So 0 0 1 1 we need to enter, only four values. 0 0 1 1. Okay, next the sixth one, which of the following filters are bifostable? Okay, now first one, the moving average, h of n is equal to del of n plus del of n minus 1 by 2. Then the h of n is del of n plus del of n minus 1 by 2. When you write this as a sequence, 1 by 2 comma 1 by 2, which is nothing but the impulse response having only the two samples, FAR, simply it is stable. Next, the following smoothing filter, summation k from 0 to infinity 1 by k plus 1 del of n minus k. Okay, this value is so h of n value is greater than 1. Summation k from 0 to infinity 1 by k plus 1 del of n minus k. Now when you compute this value, obviously this value is greater than 1. Okay, so that you can verify. At k is equal to 0, this is del of n plus del of n minus 1 plus del of n minus 2, so on. Okay, so this value is simply that greater than 0 when you are taking the summation n from minus infinity to plus infinity. When you are adding all these terms, simply value is greater than infinity, so it is not the stable function. Third one is any filter h of n with finite support bounded coefficients. So obviously it is finite support bounded coefficients, obviously it is stable. Now the step function h of n is equal to e of n. Again the h of n is equal to the e of n. Now for the bifostable, the condition is n from minus infinity to plus infinity mod h of n value. So that is n from 0 to infinity 1, which value is infinity. So it is again unstable. So only the first one, the moving average filter, and the filter h of n with the finite support and the bounded coefficient, these two are the stables. Next, the seventh one, consider an LTI system H when the input to H is the following signal. Okay, here having only the two samples at n is equal to 0 and 1. Then the output is having the three samples minus 1 at n is equal to minus 1 and n is equal to 0 and n is equal to 1. Assume now the input to the system is x1. So what is the output? So using the first two, that is input and the output, we try to estimate the impulse response of the system. We'll see the seventh one. Again the x of n is equal to 1 and the minus 1, and the response y of n is equal to 1 minus 1 1. So this is at the origin. So let the samples let the impulse response is h of n. So the y of n is summation m from 0 to 1 x of m h of n minus m. So I am finding that y of minus 1. Why? Because I know the value, which is summation m from 0 to 1 x of m h of minus 1 minus m. When you are expanding this, what will you get? X of 0 h of minus 1 plus x of 1 h of minus 2. substitute the input values, input and output values. Y of minus 1 value is, so it is 1. So 1 is equal to h of minus 1 minus h of minus 2. Okay, let's take it as equation A. Then similarly find the y of 0. Y of 0, what happens? That you will get the x of 0 into h of 0 plus x of 1 into h of minus 1. Okay, with this h of 0 minus h of minus 1, which value is equal to y of 0? Y of 0 value is minus 1. Let us take this as B. Next, y of 1 value. Y of 1 value is x of 0 into h of 1 plus x of 1 into h of 0. Now see its value, h of 1 minus h of 0 is equal to y of 1 value is 1. Let us say it is C. Similarly find the y of 2. Y of 2 value is x of 0 into h of 2 plus x of 1 into h of 1, which is nothing but h of 2 minus h of 1 value. Y of 2 value is simply 0. From this you can write h of 1 is equal to h of 2. Similarly, when you are finding the y of 3 and y of 4, what will you get? X of 0 into h of 3 minus or plus x of 1 into h of 2. With this, h of 2 is equal to h of 3. Now finding all the values, you can give the conclusion that h of 1 is equal to h of 2, which is equal to the h of 3, which is equal to h of 4, and so on. Okay. Now the impulse response having the same values from n is equal to 1 to infinity. Clear? We'll try to find those values. So I am assuming the impulse response for the negative time is 0. Okay. So why am I assuming the h of minus 2 is 0 means, so the response is start from the minus 1, okay, and your the sequence is start from 0. So obviously there is a non-zero value at n is equal to minus 1 in the impulse response. So I am assuming that before that the impulse response is 0. Okay. So when this impulse response at n is equal to minus 2 is 0 means from A, equation A, so what happens? H of minus 2 is 0. Simply h of minus 1 is equal to 1. So h of minus 1 is equal to 1. Okay. Now substitute this h of minus 1 equation B. Okay. Now from equation B, what happens? From B, what is equation B? H of 0 minus h of minus 1 is equal to minus 1. So that is, I am writing again, h of 0 minus h of minus 1 is equal to minus 1. Substitute h of minus 1 here. So h of 0 value simply 0. Okay, now substitute these values in equation C. Equation C. H of 1 minus h of 0 is equal to 1. So h of 1 minus h of 0 is equal to 1. That means, what is h of 1 value? Is 1. Now see this relation, h of 1 is equal to h of 2 is equal to h of 3. All these are equal. That means the impulse response is 1 for n is greater than or equal to 1. So now I am writing the impulse response. H of n, its value is 1 at n is equal to minus 1, and it is 0 at n is equal to 0, and it is 1 where n is greater than or equal to 1, and it is 0 else, and it is 0 else. Okay. Now we need to find the response of a system for the input x1. So here x1 is having the 4 samples from n is equal to minus 1 to n is equal to 2. Okay, simply the convolution between the x1 and their impulse response. Now see, the given x1 sequence is, x1 sequence is minus 2, 1, minus 2, 3, and this is the origin. and impulse response h of n is, you know that its value is impulse response value is 1 for my n is equal to -1, and it is 0 at n is equal to 0, and it is 1 for n is greater than or equal to 1. Okay, now here I am using the matrix method to perform this. So here I am writing the input -2 1 -2 3, so it is 1 0 1 1 1 1. Now see, -2 1 -2 3, these are the zeros. Next, -2 1 -2 3, -2 1 -2 3, -2 1 -2 3, -2 1 -2 3, and so on. Now the first one is okay. Here also we need to include that -2 1 -2 3. We'll see the response is first is -2, then 1, then -2 -2 is -4. Here only I am writing the values. This is -2 and its value is 1, and its value is -4, and its value is +2. Okay, and its value is -3, and the remaining values are 0. Now after this -2 -2 -4, 1 plus 0, and again the 0. When you are adding the remaining, all the values are simply zeros. So what is the origin value? See, for the input the origin is here, and for this the origin is here. Where we taken the product, this is the product. So there is a third block. So this is the origin. Okay, this is your the output sequence. -2 1 -4 2 -3. -2 1. See this one, the -2 1 -4 2 -3. This is your output. Okay, now the eighth one. Now the eighth one, consider the system shown below, consisting of a cosine modulator at a frequency omega naught, followed by an ideal bandpass filter h of n, whose frequency response is also shown in the figure. Assume that the input to the system is the signal x of n, whose spectrum is shown below. Now this is the spectrum of your x of e power j omega, that is the spectrum of your input signal, and h of e power j omega. Okay, so we need to find third, determine the value of omega naught that maximizes the energy of the output y of n when the input signal is x of n. So when we get the maximum energy, means when this complete spectrum is passed to the filter, then only we'll get the maximum energy. For that, so see here the input spectrum that exists from the -π/4 to +π/4, and the magnitude response of h of e power j omega is, that is from π/4 to 3π/4, and the -3π/4 to -π/4. So that means your spectrum must be shifted toward the right side and the left side by an amount π/2. So omega naught value should be π/2. So I will write this pi divided by 2. Okay. Now the ninth one, consider a low pass filter with the following frequency response. Okay, h of e power j omega that is given, which is from the -π/2 to +π/2. Okay, what is the output y of n when the input to the filter x of n is so and so. Okay, now see, again the magnitude response of the filter mod h of e power j omega minus pi by 2 to plus pi by 2. Okay, so that is h of e power j omega value. I'm writing as a function. Its value is 1 plus 2 omega by pi from minus pi by 2 to 0, and it is 1 minus 2 omega by pi from 0 to pi by 2, and the given input x of n is cos of n pi by 5 plus sine of n pi by 4 plus 0.5 cos of 3n pi by 4. Okay, they're asking to find the y of n. Clear? Now find the x of e power j omega dtft of the signal, so that you can write 1 by 2 into del of omega minus pi by 5 plus del of omega plus pi by 5 plus sine of n pi by 4, that you can write the j by 2 del of omega minus pi by 4 minus del of omega plus pi by 4. Okay, plus 1 by 2 into again 1 by 2 del of omega minus 3 pi by 4 plus del of omega plus 3 pi by 4. Now normally the response y of e power j omega is nothing but x of e power j omega into h of e power j omega. Okay, now multiply these two. That is y of e power j omega is, what is x of e power j omega? The whole thing, that is 1 by 2 into del of omega minus pi by 5 plus del of omega plus pi by 5, which is multiplied with h of e power j omega plus second term j by 2 into del of omega minus pi by 4 minus del of omega plus pi by 4, that is multiplied with again h of e power j omega third term plus 1 by 4 into del of omega minus 3 pi by 4 plus del of omega plus 3 pi by 4, that is again multiplied with h of e power j omega. Now see the impulse response, the frequency response of the system that exists from the minus pi by 2 to plus pi by 2 only. The remaining all the period, that is 0. Now to see the third term. Okay, here the del of omega minus 3 pi by 4, that becomes 1 only at omega is equal to 3 pi by 4. So del of omega minus 3 pi by 4 into h of e power j omega, that gives h of e power j into 3 pi by 4. So frequency response at omega is equal to 3 pi by 4, its value is 0. Simply this third term completely 0. Third term is completely 0. Now see the remaining is, so del of omega minus pi by 5 into h of e power j omega, that is C. So h of e power j, so this directly I am writing the time domain function y of n, applying j pi by 5 and into it is multiplied with e power j pi by 5. Yeah, simply the time shifting property. Okay, next the second term plus h of e power minus j pi by 5 into e power minus j pi by 5 into n plus The next term, j by 2 into del of omega minus omega c actually you will get here the minus. Here also you will get the minus because first time you written omega minus omega c, so it will get the minus. So it is h of e power j pi by 4 into e power j pi by 4 n minus h of e power minus j pi by 4 into e power minus j pi by 4 n. So now find the values of h of e power j pi by 5. So h of e power j pi by 5. So that is, the value is 1 plus, so this is at omega is equal to pi by 5. That comes under the pi by 2 to 0 range. So 1 minus 2 into omega by 5. So it is nothing but 1 minus 2 by 5, which is 3 by 5. Similarly, you will get h of e power minus j pi by 5 also. That is 1 plus 2 into minus pi by 5 by pi. So its value again 3 by 5. Similarly, find h of e power j pi by 4. Okay. Its value is directly 1 minus 2 into pi by 4 by pi. Its value is 1 minus 1 by 2. It is 1 by 2. So substitute these values. Now y of n becomes 1 by 2 into 3 by 5. 3 by 5 also I am taking the common. The remaining term is e power j pi by 5 minus e power minus j pi by 5 n. Okay. So minus j we have that. So minus j divided by 1 by 2, that is h of e power. I am taking this out. Next, e power j n pi by 4 minus e power minus j n pi by 4. Okay. Now the answer is that is 3 by 5. This is nothing but e power j theta minus e power minus j theta divided by 2 we have. E power j theta plus e power minus j theta divided by 2, which is cos of n pi by 5. This I am writing the minus j by 2 as plus 1 by 2j. So it is simply the 1 by 2, just multiply with this, and it becomes the sine of n pi by 4. 3 by 5 into cos of n pi by 5 plus 1 by 2 into sine of n pi by 4. Write it. By 5 into cos of n into pi divided by 5 plus 1 divided by 2 into sine of n pi divided by 4. That's your answer. Let's see the 10th one. Here, two systems are connected in the cascade. One having the impulse response h of n, the second is h of minus n. Okay, the overall impulse response they represented with the g of n. They are asking the what is the phase of this? Now see. So the g of n is nothing but simply when the two systems are connected in cascade, the overall impulse response is a convolution between the two impulse responses. So in frequency response, g of e power j omega is nothing but h of e power j omega into h of e power minus j omega. So obviously the phase is g of e power j omega phase, sum of these two. So it is 0. Okay. Next, 11th one. Let x of n is equal to cos n pi by 2 and h of n is equal to 1 by 5 sinc of n by 5. Compute the convolution between these two and write the value of y of 5. Now, so given the input sequence, x of n is equal to cos n pi by 2 and h of n is 1 by 5 sinc of n by 5. Try to represent these two in the frequency domain. X of e power j omega is 1 by 2 del of omega minus pi by 2 plus del of omega plus pi by 2. And similarly, h of e power j omega value. So here the omega c value is that is nothing but 1 by 5 is equal to omega c by pi. So it is pi by 5. So discrete time Fourier transform of single function is simply the rectangular function of 5 omega pi 2 pi. Okay. Now the output y of e power j omega. So is the rectangular function, the range is pi by 5. The final output is a product of input and frequency response. So that is 1 by 2 into del of omega minus pi by 2 into the rectangular function of 5 omega by 2 pi, okay, plus del of omega plus pi by 2 into rectangular function of 5 omega by 2 pi. See, this is the impulse signal that exists at the pi by 2, only at the pi by 2, and this is 1 from minus pi by 5 to plus pi by 5. So there is no common, so simply the product is 0. Okay, now the y of 5 value is simply 0. Next, 12th one. Consider the system below where h of e power j omega is an ideal low pass filter with a cutoff frequency omega c is pi by 4. Okay. Now consider the two input signal to the system. X1 is band limited to minus pi by 4 to pi by 4. X2 is band limited to. So okay. Now the 12th one. So again the x1 of n, which is a band limited to minus pi by 4 to plus pi by 4. Okay. Now we need to check the which signal is allowed and which is attenuated by this system. Which is multiplied with minus 1 whole power n, which is a filter. After the filter version again it is multiplied with minus 1 whole power n. This is your response y of n, x of n. Let the first x of n is equal to x1 of n. Okay. They already given that the filter is band limited to, filter is a low pass filter having the cutoff frequencies and the cutoff frequency is pi by 4. So h of e power j omega, that seems to be like this. it is 1 from minus pi by 4 to plus pi by 4 since it is ideal. Okay, now the x1 of n, the first sequence, which is also the band limited to the minus pi by 4 to plus pi by 4, but when it is multiplied with the minus 1 whole power n, so the function here I am representing as x1 dash of n in frequency domain, that is x1 dash of e power j omega, which is equal to x1 of e power j omega plus pi omega plus pi. Okay, this is multiplied with what happens, this whole term is again the multiplied with h of e power j omega. Now this function, see, the x1 of e power, that is shifted by an amount of pi, so this comes under here the complete out of that filter range, that is out of the from minus pi by 4 to plus pi by 4. So this signal completely attenuated. So the output of this filter is simply 0 when the input is x1. Okay. Now see, if you are applying the second one, if the input is x2, so that having the frequency spectrum like this, which is from minus 3 pi by 4, and this is 3 pi by 4. This is x2 of e power j omega. So then x2 of e power j into omega plus pi. So what happens? This spectrum is shifted within the range from minus pi by 4 to plus pi by 4. Okay. So the same signal, the x2 of signal, that will be passed through the filter. After that, what we are doing, again you are multiplying with the minus 1 whole power n, the same frequency component will be back to its same positions. So in this case, the second signal is attenuated by the filter. So first signal is attenuated by the signal x1 of n, and the second signal is not modified by the system. So x2 of n is not modified by the system, while x1 is eliminated. Okay. Now the third in the x1 of n and the x of n and the y of n are two square summable signals. X of e power j omega and y of e power j omega are their corresponding DTFTs. We want to compute the value of summation n from minus infinity to plus infinity, x of n into complex conjugate of y of n. Okay, this is simply the 1 by 2 pi integration from minus pi to pi x of e power j omega complex conjugate of using the property directly. Okay, and the next one, again we have the filter here. H of n is the impulse response of the ideal low pass filter with the cutoff frequencies omega c is less than pi by 2. Select the correct description of the system represented in the following figure. Now see, again the h of e power j omega, its value is 1, omega c is less than pi by 2. Okay, now they are given the one system, cos of n pi by 2 whole square into h of n. This is the response y of n. This is x of n. Okay. Now see, here I'm writing the y of n, that is nothing but, let us say it is w1 and it is w2. First, y of n I am writing as w1 minus w2. w1 is nothing but, so the convolution between these two. So x of n is convoluted with cos square of n pi by 2 into h of n. Okay, minus W2. W2 is nothing but the convolution between the W1 and H. The W1 is nothing but again the first term. So it is x of n is convoluted with cos square of n pi by 2 into h of n. This whole thing again the convoluted with the h of n. Okay. Now x of n is convoluted with this cos square theta I am writing in the 1 plus cos 2 theta by 2. So that's 2 I am taking this. So 1 plus cos 2 n pi divided by 2 into h of n minus x of n again the convolution with 1 plus cos 2 n pi divided by 2 into h of n, that is convoluted with h of n again. So I am taking this 1 by 2 out. So I am finding the DTFT of this signal. Okay, here the convolution of these two is nothing but the multiplication in frequency domain, that is x of e power j omega into the first one is h of n, so that is h of e power j omega. The second term is x of n is convoluted with cos 2n pi into h of n, so that is x of e power j omega. So multiply with the cos is nothing but there is a change in the frequency, that is 1 by 2 h of e power j into omega minus pi. Let us see. Okay, h of e power j omega minus pi plus h of e power j into omega plus pi. Okay, this is simply the convolution result of the first term. Next, the second term is minus 1 by 2 I am writing. The first term is x of n is convoluted with h of n convoluted with the h of n, so that is x of e power j omega, and you can write as a h square of e power j omega. And the next term is plus x of n is convoluted with cos n pi into h of n, again convoluted with h of e power j omega. So that is nothing but x of e power j omega, again 1 by 2 into h of e power j into omega minus pi plus h of e power j into omega plus pi. Okay, this whole thing again multiplied with h of e power j omega. Okay, now see here, h of e power j omega into h square of e power j omega, this even the square its value is 1 only, so this term and this first term will get cancelled. And here now see this one, so h of e power j to omega minus pi nothing but that is shifted by an amount pi, so it becomes it exists at the high frequency components omega. Now that is passed to the filter h of e power j omega, which having the cutoff frequency is pi by 2. So the filter output is simply 0. Why? Because this allows the frequency components up to pi by 2. Now after the shifting operation, the h of e power j into omega minus pi and the h of e power j omega plus pi, this will be appear out of the minus pi by 2 to plus pi by 2 range. So the product is simply 0. So here we have only one term. This. Okay. Now the overall system is this is your system function, which is h of e power j into omega minus pi plus h of e power j into omega plus pi. So with the magnitude is 1 by 2. So what happens now? So it is simply the high pass filter with the cutoff frequencies pi minus omega c. And what is the gain? The multiplication factor is 1 by 2. So the gain is 1 by 2. Now see the options. So it is a high pass filter with the gain is 1 by 2. Okay, gain is 1 by 2 and the cutoff frequency omega minus omega pi minus omega c. Cutoff frequency is pi minus omega c. Now the 15th one, consider the following system where h of e power j omega is a half band filter, nothing but the low pass filter with the cutoff frequency is pi by 2. Again, it exists from the minus pi by 2 to plus pi by 2. Okay, this is the system, and assume here the input is del of n, compute the summation n from minus infinity to plus infinity y of n. Now see here, so they give in the h of e power j omega, its value is 1, the mod omega c is less than or equal to pi by 2. Now the given filter is h of e power j omega which is multiplied with minus 1 whole power n, which is minus 1 whole power n into w of n. We call it this. It is plus here the input x of n. So given the input is x of n is impulse signal, and they are asking to find the summation n from minus infinity to plus infinity y of n values how much. Okay, are this y of n directly you can write is 1 plus e power j n pi into omega of n. Okay, 1 plus, this is not simply multiply the minus 1 whole power n, nothing but the e power j n pi, cos n pi plus j sin n pi. Cos n pi is minus 1 whole power n. Okay, now the 1 plus e power j n pi, e power j n pi value is minus 1 whole power n. W of n is nothing but is a convolution between the input and impulse response. So it is x of n is convoluted with h of n. Okay, now the frequency domain y of e power j omega, it is the first 1 into x of n is convoluted with h of n. So simply you will get x of e power j omega into h of e power j omega plus next one is convoluted with e power j n pi. So it again the convoluted with tft of 1 plus e power j n pi. Okay, so here this the multiplication of two functions in time domain, nothing but the convolution in frequency domain. So the 1 plus j n pi, its equivalent frequency domain that I written as the discrete time Fourier transform of this function, and the frequency domain equivalent of x of n convoluted with h of n is simply the multiplication equivalent. Okay, now so here the x of e power j omega, since the input is an impulse response, so this is h of e power j omega only. X of e power j omega value is 1 is convoluted with, so discrete time Fourier transform of this function, this is discrete time Fourier transform of 1 is nothing but the del of omega plus e power j n pi is nothing but the del of omega minus pi. Okay, now the convolution of these two, the convolution of these two is h of e power j omega into del of omega plus h of e power j omega into del of omega minus pi, del of omega minus pi that exists at omega is equal to pi. Okay, at that time h of e power j pi value is simply 0, so the second term is 0 and this value is 1. So y of e power j omega value is 1. Now from this one, what is y of n? Simply impulse signal del of n. So the summation n from minus infinity to plus infinity, y of n value is simply 1. Okay, now I will see the results. Okay, thank you for watching.